and this is very important for many of you that are starting out in your early career, that your sphere of influence may be at times ridiculously small. But don't give up on that. At least identify the problem, and if it's bigger than what you are and can get consensus on, at least break that into smaller pieces of what you can impact. It's also good to investigate. That's where we collect. And this author has the audacity to use the word facts here. And I encounter this frequently as well, that one situation come up where 50% of things were bad, and is that 50% of 1,000 or 50% of 2? Make a big difference on that. The next thing after you've collected that is analyze. I'm getting too excited, I should write slower. So we're looking for possible causes. And we also like possible solutions. I've had one supervisor tell me at one point in my career that no sense bringing me any problems until you at least have an idea of how to fix it. So it's one way to weed out how much information he had to go through, is that if there was not a solution on what's going on, don't bring it to him. Next thing is we're going to try to solve this. And here's another important one that's easily overlooked, is confirm the results. We're going to talk about these scatter diagrams in a while, and just because there's a relationship does not mean it is cause-effect. So sometimes you might address a symptom and it's not actually fixing it. All right, so these are the steps necessary to start looking at our tools here. So identify the problem in the project scope. I'll go through these very briefly and we'll come back to them again a little bit later. If you're looking for potential causes, that's where we're looking in this analyze step. This crude representation here is a fishbone diagram or cause-effect diagram. Once you're in the collecting data phase, that is your check sheets, tally sheets to be used in that situation. Once you get past collecting the facts, analyzing, we have 4 of them represented here. We have our Pareto, which is our vital few, the most significant on the left, scatter diagram, cause-effect relationship on the upper right, histogram in the lower right, and control charts. If you come out with a solution, I've included this graphic of the PDCA, the plan, do, check, and act. That Deming wheel of IMP stands for implement. All right, so if your solution is not useful enough, you might need more detail, so that puts you back at collecting more data or tally sheets. I find it very interesting that a lot of companies don't use these sheets as much as I think could or should. Having data collection right at the source of to track that. I think we talked about it previous sections that while it's fun to collect data just because we have a computer to collect it and store it, it's important still to act on what you collect. Does that kind of make sense? So in other words, if you have a machining center where you're running into a quality problem, get a check sheet to collect that data, and then you need to start acting on it very quickly, relatively quickly. What should you do with that? All right. So the first one we're going to go into of these potential causes is cause-effect diagram. Does anyone happen to know the name of this tool, or who is one of our quality practitioners that developed this in the past. That's right. So it's not important that you know that person's name, but if you do run across that type of description of this, it's one and the same. It's also what's called a fishbone diagram. And so here's where you have your quality issue or quality problem as the head, and then each of those bones coming off of that. So we're going to break this diagram into some major pieces. So we're going to start with our problem statement. That is the head of the fish. Frequently, at least our author calls this 4M. What's that's referring to is the each of these main areas are manpower, methods, machine and material. And the reason it's called the 4M is frequently a problem statement can be broken into these four main aspects of that. We can add a couple extra ones to that. Measurement and the environment. So the goal of a cause-effect diagram is to I'm going to call it graphically summarize. So it's a way to break a problem statement into different sections. Recognize also you can break these into smaller subsections if you need to. Any comments from those of you who have used cause-effect diagrams?
Just that you should get to know it, because in the auto industry it's a requirement, in the industry we're in, medical, it seems like it's very common. It's the first thing in an AP the customer wants to see. Where are the potential escape points, and are you addressing every one of them in your AP corrective action? You'll get used to it.
Is it correct in your experience, Jeff, that these are the start with 4M, or is it 6 that are frequently?
4M is what we were taught in the 80s and 90s and used it, but environment is definitely on there. I would argue that most of the measurement in environment could be under method. You know, management tells us how to do our job, how to measure it with what, and the environment, how to control the environment. But yes, more commonly it's expanded beyond 4, and it includes measurement and environment.
I would also state that some industries may have more emphasis in different pieces of this depending on what your products you're making. Shan, any thoughts on it?
No, I agree with him. We used to use this at the with Palo when I worked there, and actually most of the time we used 5. We didn't usually include the environment, and we used them a lot during our Kaizen events. That was our main cause and effect for line downtime problems.
So it's a great way to divide into this next, there's 3 parts our author mentioned I thought were good to bring out. And what I mean by this is a fishbone session or cause-effect. Frequently it's done in a group environment. It can be done by one person, but it's helpful to have more than one. And the first one is brainstorming. Two, prioritizing. And then the development of action plan. I think that is easily overlooked, or maybe it's part of that maturity process of using these diagrams. Is after you've identified and created the graphic, you may, the idea of this is to actually bring about change or an improvement, so then that would be handy. All right, any other comments about?
One item to note on brainstorming. It seems like common sense, but in brainstorming, don't ever throw out any of the ideas. Doesn't matter how off the wall they are, because sometimes you'll branch off of one of those off the wall ideas and come up with your best idea. Brainstorming, in brainstorming, you capture everything, not just the things that you think you're going to use.
I want to ask a question for Jeff related to that. If we put every possible thing on here, does having it on the list, even if it doesn't, if there's no proof that that has contributed to the problem, is that still acceptable, or is it only ones that are?
It's a really good point. Brian and I did one recently, and the idea was put as many as you felt were comfortable, combine them where it made sense, but circle the ones that you thought you'd find causality, that were the root cause. And as soon as you circle one as a potential cause, the customer really expects you to then attack that one with preventive action or corrective action. So I don't think there's a wrong answer. Combining them makes sense, not overly complicating it. But when you circle them as ones that the team has identified as the key ones, then you really open yourself up for what action did you take.
So that's part of the circling is the prioritization, and then the expectation that once you've highlighted it, that you're going to act on that corrective action.
From an example would be from a method standpoint, kind of your work instructions, how you're going to do it. Your work instructions could be incorrect in the documentation that you're using to build the assembly, but you also could have like training historical work instructions. So when you're going after any corrective action, you need to look at which ones are wrong, or is it multiple? And then you rule the ones that were thought of in brainstorming as being, these are options for this could have been incorrect and leading to this. Then they get left on the fishbone, but they're not confirmed root causes to your problems.
So very briefly, I'm going to do a quick cause-effect diagram. What should be the topic of interest that we do this for, just to make this a little more interesting? Maybe. Not many people here like improv, huh?
This might be customer returns. That seems to be the one that generates the most action in a lot of manufacturing facilities.
It's true. So what are some examples of when you have customer returns, what is a manpower issue that may be part of that? We'll be in the brainstorming phase here.
People doing 2 jobs.
Say again about the 2 jobs?
People doing 2 jobs on an assembly line. So.
Not just following their standard work.
Multitask.
Yeah.
Temp labor.
2 hires.
Shift change issues.
Overtime.
All right, good. Now we'll move on to methods.
Fast.
It sounds like we've dealt with some of these before.
Been there, done that.
No work instructions, wrong work instructions.
2 sites building the same product.
How about on the machine?
Go back to the method.
All right, maybe
Anything
go
about
ahead.
spec?
Specifications?
Ambiguous specs.
How about on the machine? That'd be like
Equipment.
tools.
What'd you say?
New equipment.
I want to add settings, like if you have too high of air pressure, too low of air pressure, Maintenance?
Equipment,
Downtime,
maintenance.
unscheduled downtime,
How about on the materials?
There are no materials issues.
This is just hypothetical.
Wow.
Or maybe for other companies.
yeah. Suppliers couldn't make it available, so availability. Anything wrong?
No markings.
Counterfeits?
No visual.
Multiple sources.
Variation. How about on the measurement side?
Wrong gauge,
Lack of calibration.
right?
Training.
Which one, Ron?
Well, training, I guess that's going with not manpower.
Test correlation.
I think the training is still, or maybe we could just say measurement method.
MSA, sure.
MSA, measurement systems analysis. Maybe we're using a measurement method which is not reliable enough to even discern what the problem is, and we don't even know if we're hitting the rest of those. How about on the environment? We got humidity, temperature. Those two are almost always present. Say again?
UV.
UV.
Clean air.
Plastics and all, that's your heat returns pretty much.
Dust.
And just clean. Vibration sometimes can be.
Sure.
Oh, had to bring that up.
Oh, I'm just pulling that out of thin air.
Sensitive one.
We'll move on before it's personal. So that's a cause effect.
So before you erase it,
Sure.
so if you're looking through, we've just brainstormed all these multiple items as this could cause returns. When you do this on a specific example, you might have a little bit more detail than just returns. You might say returns for blank. It could be missing part, damaged part, non-functional part, intermittent. And you'd go through these different categories that you've listed, and normally you're keeping in mind as you investigate that failure mode. And that's why you're getting them on this tree. So before you take them off and decide they're not a root cause, you have to review them. We didn't populate something at a certain reference designator. Were the work, starting with method, were the work instructions correct? Were the specifications clear? And so you go through and they come off the list.
So you actually use this as a checklist, if you will, to make sure that those possible causes did not cause.
Right, possible causes driving to root causes, that's the most common use that I've used it for, is in 8D corrective actions Jeff mentioned earlier. And so you go through and you say, all right, no, it wasn't the work instructions, no, it wasn't the specs. And then you get to new hires and you look at, oh, we had to, this never happens. And it literally has not happened for us. But you get to new hires, it was just the first one I saw, and oh, look, we hired 700 new employees and our returns rate for this general one went up.
So let me ask you.
So you'd circle it and say, hey, there's a direct relation there, most likely.
So a follow-up question related to that is, if you say it does not exist, what evidence do you have to give that it doesn't exist? In other words, this is almost like a philosophical question, but is there a obligation to show that it is not, or is the absence of evidence that it is means that it's not
I think the
certain?
latter is true. The 80-20 principle prevails. The team chose to focus on these because we could circle them, as opposed to this is why we didn't circle them.
All right.
And in a lot of cases, you get down to, and I mean, you change the ones that were wrong, you do work instructions. We got returns because we got a whole bunch of parts back. The work instructions didn't say to install RTV on a part going to the vibration thing. Therefore, they didn't have RTV installed and they failed because of the combination of the work instructions and the vibration. So now you've had two root causes. One of them is vibration. One of them is that your work instructions didn't tell you to install RTV. And you can kind of see how all the other ones we listed would start going away. Training wouldn't matter because the work instructions weren't there.
And
So-
I've not seen people focus, as Brian's saying, on the ones that weren't
Right.
identified. Not really seen that on 18.
Right, no, I'm just looking at it
Yep.
from my standpoint. I'm the customer, and sometimes I've seen where the supplier wants to drive down a path. I'm like, I don't
A
think that.
predetermined path most
Yes.
likely.
And the ones you pick, you should, with the evidence thing, you should be able to evidence that this was the reason, the root cause of that happening, to the point where you'd say, all right, the other one doesn't make sense anymore, because I know that happened.
I think we'd all agree that the 8B would drive us to verify the effectiveness of the
Yep.
corrective action. So if the problem persists, that's evidence that we didn't choose the right one, and that would cause the team to go identify the problem again. And go search, create alternatives, select alternatives.
So Jerry, why did, in your experience working with suppliers, why does suppliers not want to investigate everything? Cost.
Cost, or
Yeah, limited
there's another one,
resources.
well, the related to cost is effort. That if you go down a certain path, it's like, I don't really want to have to rewrite the work instructions, or convenience may be related to that. It really depends on the maturity of the organization that
Yeah,
you're
and
dealing with.
we live in a pretty competitive, we're all in a pretty competitive environment economically.
That really brings up.
We don't have unlimited resources. All of us have limited resources. How do you prioritize?
That brings up a really good point, is that ISO really doesn't want us to add cost to a product. They only want us to add value. And inspection and investigation, we would all agree, add cost and not value.
Yeah.
So I think